Okay, so tonight I'm going to be talking about how sound is made if you look over on PowerPoint 1. Slide 2, we're going to be going over physical sound, like how it's created, what it is, and then the 5 different parts of the human ear. We're going to go over the outer ear, the eardrum, the bones, the cochlea, and the auditory nerve. Slide 3, we're going to be talking about physical sound. So physical sound happens when two objects collide with each other, or in the case of a speaker, when air is compressed and refracted. The speaker does that by basically just pounding on the air and pushing it forward. And so it creates little waves, sound waves, by just moving the air kind of closer together or farther apart. So the first part we're going to talk about the human ear. It's going to start on slide 4. We're going to be talking about the outer ear. So the outer ear is the part that you can see, and it works kind of like a funnel. It takes the sound and just squishes it down and moves it towards the eardrum. And it kind of speeds up the waves slightly just because they're going from bigger to smaller. Slide 5, we're talking about the eardrum. So we all know what the eardrum is. So we're going to be talking about how it works. So it turns sound waves into vibrations, and the way it does this is the sound waves, the compressed parts hit it, and it moves and hits up the ear bones, so it kind of just pushes them, and it moves the sound waves from moving in the air to moving through physical mediums. And because the eardrum has a bigger surface on the outside than on the inside, it speeds up the sound, so it makes the waves even closer together, even faster, and it also makes sound louder. So if you go over to slide 6, we're going to be talking about the bones in the ear. So there's 3 bones in the ear. The malleus, which is the hammer, and the malleus takes the vibrations from the eardrum and moves them and hits against the incus, which is Greek for anvil. And then the anvil moves them in the same way across to stapes, which is basically the diffuser. Moves the vibrations from the bones and kind of diffuses them evenly throughout the cochlear fluids. And that brings us to slide 7, which is the structure of the cochlea. So if you look at the picture on the slide, we have the tympanic duct, which is the part on the outside, the smooth part. And then you have the cochlear duct, which is the kind of stripy part on the inside of the swirl. And those dark stripes you see on the inside of the cochlear duct are hair cells. And what they do is, and then the kind of shaded part on the other side of the hair cells is the auditory nerve. And then moving over slide 8, we're going to go into the cochlea function. So the tympanic fluid, which is kind of a watery substance in the tympanic duct, it collects all the vibrations, and when vibrations move through from bones or air into liquid, it slows them down, which is why it was important for the outer ear and the eardrum to speed them up in the first place. And it collects the vibrations and then makes waves, and the hair cells kind of ride the waves. And as they're doing that, it irritates the gland, next to the auditory nerve, and that gland releases chemicals that it produces. Moving on to the next slide, we have the auditory nerve, which is the part we're at now. So the hair cells, if you look at them, they have the little hair parts, and the structure down beneath that structure collects the chemicals and moves them to the auditory nerve synapses. So nerve synapses are little chemicals at the beginning of nerves that react with the chemicals they're receiving, and that creates an electrical impulse. So once those chemicals from the hair cells reach the auditory nerve, it's going to create an electrical impulse which can then be sent to the brain through the nervous system. So, just to review, I have an ear diagram right here. And we're going to start with the outer ear. Again, the outer ear works like a funnel, funnels it all straight to the eardrum, which takes those, creates vibrations by basically being pushed against the ear bones. And that funneling is going to cause those sound waves to speed up. The eardrum, again, is kind of like another funnel. It's going to speed them up, make them more faster. And then you get to the ear bones, which are going to vibrate against each other one after another. You have your hammer, you have your axle, and you have your diffuser. From the bones, they're going to move straight over into the cochlea, which is that swirly bit, and the cochlear fluid is going to collect it. And then the second chamber, the cochlear duct, with all the hair cells, is going to kind of ride those waves because it's a very elastic barrier between those two ducts. And those hair cells are going to brush up against glands in the ear, which produce chemicals, and once those hair cells brush up against it, it's going to open up pores, and those chemicals are going to flood into the cochlear duct. Once that happens, the hair cells collect those chemicals and move them to the auditory nerve. The chemical synapses at the ends of the auditory nerve will react with the chemicals produced from the sound waves, and the chemical reactions will turn it into a electrical pulse, which is then going to be sent to the brain from the nervous system, because the nervous system acts kind of like a power cord, where it can the electrodes can take an electrical pulse here and move it over here.